Good morning to one and all. Myself, P. Agnesha. I am from CSC branch A section. Today, my topic is implementation of stack using linked list. Introduction to stack and linked list. A stack is a linear data structure that follows the last in first out principle. A linked list is a data structure consisting of nodes where each node contains data and a reference to the next node. Implementation a stack using a linked list allows for dynamic memory allocation and efficient use of storage. Characteristics of a stack. Stack support two primary operations: push adding an element and pop removing the top element. The stack can be empty, which is referred to as underflow or full. This is not applicable in a linked list implementation. The last element added to the stack is the first one to be removed, adhering to the LIFO principle, that means last in first out. Advantages of stack using linked list. Linked list implementation allows for dynamic sizing, overcoming the limitations of fixed size array. Memory can be allocated for elements as needed, reducing waste compared to an array-based stack. There is no need for resizing or reallocation, which can improve performance in certain scenarios. Structure of a node. Each node in a linked list stack typically contains two components: data and a pointer to the next node. The data component holds the value of the element being stored in a stack. The next pointer links to the subsequent node in the stack or is full if it's the last node. Stack operations push. The push operation adds a new node to the top of the stack. A new node is created, initialized with the data, and its next pointer is set to the current top node. The stack pointer is then updated to point to this new node, making it the new top of the stack. Stack operations pop. The pop operation removes the node at the top of the stack. The current top node is stored temporarily. The stack pointer is updated to the next node. The temporary node is then removed from memory, effectively discarding the top element. Stack operations peak. The peak operation reaches the value of the top node without removing it from the stack. This is useful for checking the current top element without modifying the stack state. It allows users to review the top element, enhancing the functionality of the stack. Example of stack implementation. In a simple implementation, a stack class is created with methods for push, pop, and peak. For example, pushing the values 10, 20, and 30 onto the stack results in 30 being at the top. Popping the stack would remove 30, leaving 20 as the new top element. Next, code example push and pop. Here is a simple code snippet for the push operation. Here is a simple code snippet for the push operation. Python def push self value, new node value, new node next self top, self dot top equals to new node. And for the pop operation, Python def pop self. If self top is none, return node. If self top is none, return none. Popped self, popped value, self top data, self top next. Here we have to see some pictures. Here head contains node 3 nodes, node 1, node 2, node 3. Each node contains value 1 next. Here also we can see that head and connected to 4 nodes, node 0, node 1, node 2, node, and each node here also we can contain the new node. And here stack operations like push, pop, display, exit. Choose operations 1, enter element to be pushed. Choose operation 1, enter element to be pushed. Here choose operation 3, status of elements in stack. Next, here bottom, here some indices 3 to 1, stack 100, node start pointer equals to new node, pointer to data value, pointer to link top equals to PTR. Conclusion. Implementing a stack using a linked list provides flexibility and efficient memory management. Understanding stack operations is crucial for various applications in programming and algorithms. This implementation can be extended further with additional functionalities like size tracking and error handling. Feel free to modify or add any specific content you want to include. Thank you for the given this golden opportunity.